Hello, everyone. Today we're gonna go over counting problem strategies with the examples. So previously, I gave you a lot of examples for the math competition for MathCon or AMC or AMY. Today, we're gonna talk about the strategies to solve different types of problems. Earlier, I covered the topic a little bit for balls and boxes. From today's lesson going forward, we're going to talk about this topic in 4 different types. So balls and boxes is very important strategies for counting problems. So we're going to start with the summary. We have 4 types of problems for the balls and boxes. So we have the first one, distinguishable balls and distinguishable boxes. Second one is distinguishable balls and indistinguishable boxes. Type 3 is indistinguishable balls and distinguishable boxes. The fourth type is indistinguishable balls and indistinguishable boxes. So we're going to talk about the 4 types separately. Let's take a look at the model. If you look at this one, distinguishable balls and distinguishable boxes, just like this. All the balls are different. They can be identified as different balls. The boxes also distinguishable. They are all different. So this model, we're going to put the balls into the boxes. And for example, I put these blue balls that can go to any of these 5 boxes. So the same thing for the yellow balls can go to any of these. So this model is going to be distinguishable balls put into distinguishable boxes. So this the focus for today, we're going to focus on this type. Before we go over this type, we're also going to show you the other 3 types model at a glance. You can see the second one going to be distinguishable balls put into indistinguishable boxes. For example, if you put a blue balls into any of these, its treated is the same. And then the same thing for other balls. For example, if I put blue ball, yellow ball in one of these boxes, in 2 balls in one of the boxes, that will be the same thing. Either you put these 2 balls into the first one or second one and third one, that will be the same thing. So these are the ball boxes are indistinguishable. They cannot be identified as different boxes. So this is type 2. Type 3 is going to be, this one is indistinguishable balls put into distinguishable boxes. The last type is indistinguishable balls. They're all the same. No matter where they put it, for example, I'm going to put this one, 1, 1, 1, that will be the same thing. It's just one type. One possible. If you put each box has 1, that's only 1. If I put for example, I put 2 red ball into here, and then the other one going to put the other box could be 1, 2, 0, and then you put 1, 2, 0, or 1, 2, 0, there will be no different. So these are called indistinguishable balls put into indistinguishable boxes. So today's lesson will be focused on the type 1. Both balls and boxes are distinguishable. So let's take a look. Distinguishable balls and distinguishable boxes. So let's take a look at the question then. Distinguishable balls put into distinguishable boxes. both balls and boxes are distinguishable. So the question look like this. How many ways are there to put 5 distinguishable balls into 3 distinguishable boxes? This sounds weird because in reality, in the actual problems, they may not talk about the balls and boxes at all. So the actual problem just like this. 5 passengers will be arranged into 3 different buses. How many ways are possible? So passengers are all different. And then the buses, 3 buses are all different. So that's why these passengers are treated as balls and the buses are treated as boxes. So these are distinguishable boxes, balls put into distinguishable boxes. So these are the actual problems we're going to solve. The balls and boxes just the model, just like this. Okay. How would you solve this type of problem then? We usually have 2 ways to do it. Depends on the type of problem. One way will be easier than the other one. We're going to show both methods to solve this type of problem using 2 examples. The first example, basically the first solution for this problem is how many ways are there put 5 distinguishable balls into 3 distinguishable boxes. And then just like these 5 passengers will be arranged into 3 different buses. How many ways to do it? So we use this example as the first example. And then we give you 2 different solutions. One solution in this case will be much simpler. We're going to do this way. For each ball, we are not really restricting how many passengers can go to one bus, or they can go to 1 bus or 2 buses or 3 buses. So it doesn't matter. There's no restriction. So in this case, the first solution will be much easier. We're going to say for each ball, in this case, each passenger, how many choices of which box to place in it. So that will be 3 buses. Each passenger can go to any of these 3 buses. So 3 ways to do it. Because each passenger has 3 choices. So that means the choice is independent for each of the 5 passengers. So the number of choices will be 3 for the first passenger, 3 for the second passenger, the same thing for other 3 passengers. So that will be 3 to the 5th power of choices altogether. That means the way to arrange these 5 passengers into 3 buses, there will be 243 ways to do it. So in this case, without any restriction, arrange the passenger into different buses. That means put different balls into distinguishable boxes will be very easy to do this way. Using the distribution for each of the balls can have how many choices, and then you just put them together as multiplicative counting principles. You get the 3 to the 5th equal to 243 way to do it. So that's a very simple way to solve this type of problem. But generally, we can do the second solution. That means how do you distribute these 5 passengers into 3 buses? We can just distribute those numbers in different way. Even though that may not be the best solution, but we're going to show you the second solution as well. There's 2 steps for each of the arrangement. First, you need to choose the balls. In this case, we're going to select the passengers. And then the second one, you're going to choose the boxes. For example, I'm going to select the 5 passengers. You can distribute into like 1, 1, 3. So you choose the 1 passenger and then choose another passenger and then leave the rest of the 3 passengers and then put it into the buses. And then once you select the passenger, we're going to select the boxes. So there's 2 steps for each of these arrangement. So even though this will be very complicated in this example, but I'm going to show you the method. So the first distribution, going to put the three stack or three group of people. Actually, first group, there's nobody. Second group, we put all the 5 people together. So that means the number way to select the balls, that means passengers, put these 5 passengers in one group, will be only one way to do it. So that's for selecting the balls for passengers. And then we're going to select the buses, that's boxes. So the number way selecting the boxes to put this group together, there will be 3 ways to do it. Just like a 3 choose 1. So the way for this one will be 1 for balls, 3 for boxes. You have 3 ways to do it. Second one, we distribute the 5 passengers into 3 groups this way. First group, actually nothing. Actually, the first is only 1 group. Second one, we're going to do 2 groups. One with a 4, the other one with a 4, one with a 1, the other one with a 4. So how do we select the passengers? Among the 5 people, we have choose 1 for this group with 1 passenger. And then the leftover 4 will be put into the second group. So this is 5 times 1, it will be 5 ways to select the passengers. And then after that, we're gonna select the boxes, okay? And the number we choose the boxes, you see 3 factorial way to do it, 6 way to arrange them, okay? You can put it like the first box is 0, second box is 1, the third box is 4. Or you can do first one is 0, second one 4, the third one is 1. Or you can do first box has 1, the second box 0, the third one can be 4, blah, blah, blah. And totally just a 3 factorial way to arrange to select the buses. So 6 way to do it. So the number way in this case for the distribution of the passengers into different buses will be 30. Okay, that's a second grouping. Continuously, we're doing more grouping. For example, you can put a 2, 0, 2, 3, splitting the passengers this way. You can do the number way to select the passenger will be 5 choose 2, and then 3 choose 3. For the leftover 3 will be put in a group. 5 people, we choose 2 of them as one of the group. So you get a 10 way to do it. After that, we're going to select the buses. So that's also have 6 way to do it, 3 factorial, 6 way to do it. So in this grouping, we have 60 way to distribute the 5 passengers into the 2 different buses. Okay, the fourth distribution will be put each bus has at least one of them, 1, 1, 3. So we select the passenger will be 5 choose 1 for the first group. The leftover 4, I'm going to choose 1 for the second group. The leftover will be left as third group. Regarding the boxes, we have 3 ways to select the buses, because we just select the one of the bus will have 3 passengers, 3 ways to select that. So the total will be 60. This is a 20, this is 3. The last one we can put is a 1 plus 2 plus 2. That means one bus has 1 passenger. The other 2 buses has 2 passengers each. So first of all, we select the passenger. Select the 1 passenger from the 5 for the group of 1. Select the 4 choose 2 means select the 2 from the rest of the 4 for the group of 2. And then the leftover will be for the third group. This is selecting the passengers. The way to select the bus to put the passenger will be 3 ways to do it, because that can be the first bus or second bus or third bus have 1 passenger. So totally we get a 90 way to do it. So using the second method sounds complicated. We have 5 ways to distribute the passengers. The first, you see, the first one is only one group. Second and third one, we have 2 groups. And then the fourth one, the fifth one, we have 3 groups. So totally we get all of these put together, we get the answer 3 plus 30 plus 60 plus 60 plus 90 for 5 cases, we get a 243. Compared with the first method, this will be much more complicated. Will be considering too many cases, but this is still necessary to learn this method because a lot of cases you need to use this method instead of the other one. So certainly I'm going to show you the second example. We're going to do differently using the 2 different methods. 5 passengers will be arranged into 3 different buses so that each bus has at least one of them. That means you cannot get like the group of 0, group of 2 groups only, 1 group only. So they have to be split into 3 groups. So this will be part of the question in the previous example. So I still using 2 different ways to show how many ways are possible to distribute the 5 passengers into 3 different buses. Okay, so let's see the solution 1. Still using the distribution that way, each passenger has 3 choices. So the number of ways of distribution will be 3 to the 5th power 243. But these include a case what? They all only go to 2 of the buses. So these are not actually qualified. We need to remove them, which is 2 choices for each of the passenger to go to the selected 2 buses. And also the 2 buses, we have 3 choose 2, which is 3 ways to select the 2 buses. So these, all the passengers go to 2 of the buses, we'll have 32 times 3 way to distribute it. Certainly we have the other case, maybe we just remove this too much. We need, we contain this case, include this case, they all go to 1 of the buses. So this one will be selecting the bus will be 3 choose 1. Each passenger only 1 choice to go to that selected bus. So you have 3 ways to do it. They should be added back. Based on the principle of inclusion and exclusion, the number of ways to get these passengers distributed into the 3 buses, we're going to do this way. 243 minus the case which is not qualified for the 2 buses only, leave the 1 of the bus empty. And then certainly this subtract too much, we also need to add back for the one with the all the passenger go to 1 bus. So this is called principle of inclusion and exclusion. And then you get the total number of ways to do it is 150. So this first method doesn't look like as easy as the without restriction. We also take a look at the second method. That means we kind of group those 5 people into 3 groups, split them into 3 groups. The second solution in this case will be much simpler. I mean, I only have these 2 selection 1, 1, 3, 1, 2, 2. Based on the first example, we already have that result. Select the balls. 5 choose 1 for 1 bus, a group of 1. Select 1 from the rest of the 4 for the second group. The leftover 3 for the third group. And then the selection of the boxes will be 3 ways to do it. So total will be 60. The second one, you're going to split that into 1, 2, 2. So we do the same thing. Select 1 for the group of 1 from the 5. Select the 2 from the rest of the 4 for the group of 2. And then the leftover 2 will be for the third group. The number way to distribute the select the box is going to be 3. So you multiply them out. This is a 5, this is 6. 30 times 3, you get a 90. So we get the result. So that's why in this case, that's even simpler than the other distribution using the free distribution method and using the principle of inclusion and exclusion method. This is much easier than that. Okay. I think both methods, we should get familiar with it. Okay. So that basically just give all the explanation about distinguishable balls put into distinguishable boxes. And we using the 2 examples, one with a restriction, with the other one without restriction. So with the restriction, we use the second method will be easier. Without the restriction, using the first method will be much easier. Okay. So this just conclude the method for distinguishable balls put into distinguishable boxes. Thank you for watching. Please subscribe our video in order to get the future update.